when we are storing numbers in a computer, okay, bits are our smallest piece of storage. And a bit can either be what? 1 or a 0, yes or no. So each bit can be 1 or 0. We do things in binary on computers. We're not going to go through binary. Oh, maybe this is handy now that I've seen it there. So 8 bits means that we have 1, 2, 3, 4, 5, 6, 7, 8 decimal places of precision. So if I have 1.1, 2, 3, 4, 5, 6, that's how much precision I have. So in a whole number, I need to back up. In a whole number, it's either 1, or it's 2, or it's 3, or it's 4. Computers, Intel processors love whole numbers because it's 0 or 1, right? So if we represent a third as a decimal, it's 0.3333333 into infinity. Do we have infinite memory? Well, it is 0.333 to infinity, isn't that 1/3 if you put it to, if you convert it into a decimal? Because you cannot exactly represent 1/3. There's other numbers that like 2/3. You can't exactly represent that with decimals. 1 you could, because it's 1 0 0 0 0. Doesn't change. But 1/3 can only be represented with so many decimals. Well, if we were doing 1/3, we'd have, I should probably type instead of doing my scrawly stuff here. So if I am going to do, I would do 1.3333, see 1, 2, 3, 4, 5, 6, 7, 8. That's as accurate as I can be with 8 bits of precision. But it goes 33333, so I'm chopping off the precision. Does that make a bit of difference? Sure, if you're sending the Apollo to the moon and you're off by a 0.000001, that could be a big difference. So in scientific computing especially, we want lots of precision. So 32 bits of precision is what a float gives us. We go up 32 places. That's how accurate we can be. It's not completely accurate because in the analog world, we can keep going forever, but there really isn't a forever that we can measure. We have to stop measuring at some point, and computers can't measure forever. So they have to stop at some point. So if we have 32 bits of precision, we have 64 bits of precision, which of these is going to give us the better answer?
64.
64. The disadvantage of 64 is that we do what?
Makes it longer.
Twice as much memory. It's more to calculate with. Do we always need that precision? No. Floats in Python are 64-bit precision. Yeah, I know. They just call it a float. They don't make a difference between float and double. There's also different kinds of integers. You can store different sizes of integers. With Python, it does it all for you. Java, C++, we have to think ahead and
Why do they
say,
call it a float then?
they just do. A float is the general term meaning floating point. So the point of precision can float around. That's where float comes from. It's a general term. Float is specifically 32-bit, but in Python, it's actually that much precision. They simplified it because Python is meant to be a friendly language. It handles a lot of stuff in the background. However, with Java and C++, we have to handle more of it ourselves. Which also means that theoretically, Python is a higher level language, so it has more overhead. Java has less overhead, C++ has less overhead. This is easier to program, but on the same thing, it's not going to run as fast as C++.
So can we use it in Java?
Can you use what?
That-
Yeah, we do all the time. Can you make it 32-bit? I don't know if you can or not. I've never thought about that. Python handles that for you. It's either a float or an int. And if it needs more room, it just makes more room in the background. Where in Java and C++, we say, this is it, you're done. You only get 32 bits, period. You can't expand and take any more room. We have to set the boundaries. With Python, it sets its own boundaries in the background for us. That's another computer sciencey thing.
Unless you use double.
You're still setting a boundary. If you use a double in Java and anything besides Python, Python is really a scripting language like JavaScript. TypeScript's a little different. They automatically use to whatever's been programmed in. You don't have to say, I'm doing a float. The language interprets when you type in something, oh, that's the data type you want and how much room you need. It does it for you. Because you can either have a float in Python or you can have a float. You can either have a float in JavaScript or you can have a float. That's it. With Java and C++, you can have different accuracies and say specifically, I want this much. No, I want this much. No, I want double precision. I want the next one bigger. I can go much bigger. So I
So
can,
128 bit.
I don't remember what it's called.
Wait a second, look it up.
Yeah, I mean, there's with other languages like Java and C++, there's different levels of precision. Oh, who wrote all this stuff on the screen? That would be me, wouldn't I? I thought I got rid of that. There, clear all drawings. Ah, phew. So we're looking at, you would say maybe, boy, there's stuff. Oh, I'm still in here. I need to get out. So you might say floating point precision. Precision in Python and maybe just Java. And that should bring up your different types. Yep. It tells you how to declare them. So it's single precision. This is double precision. Is there any more than that? Well, there is. Big decimal. So you have to say how much room. Oh, and I was saying that wrong before. If you have 32 bits of precision, that's in binary, not in decimal. So 32 bits of precision would be around 7 digits. I forgot I was talking about binary, not decimal, not decimal numbers. So 32 bit floating points is 6 to 7 decimal points. This is around 15 decimal points of decimal numbers, where it's 32 bits of binary, which is really what it's seeing as the binary, but we get back this many precision of, so I should probably do that. So 0, 1, 0, oh, my number is not working. So if we're looking at what the computer sees, you know, this might be 15 bits of precision. This translates into 1, 2, 3, 4, 5, 6, 7 decimal numbers. Because when you convert binary to decimal, well, you're going like this. You're shrinking it up. This is what we see as decimal numbers, and that's why it can be a little confusing. And it says it right here, it's 64-bit, but they're talking about binary. Here, it's 15 decimal digits. So that's the decimal digits we're looking at. And we typically use double in other languages. Float in Python is a double. And then they say here they want to use big double, big decimal, because in big financial calculations, you don't want to be throwing away all those pennies. You know, you want really good precision. So that would be 128. They don't say it is, but that's what it is. So it double each time. 32, 64, 128. I don't know what arbitrary precision means. Maybe it doesn't mean that's 128. But where they're saying precision issues inherent in binary floating point, well, at some point you have to stop. On the other hand, let's look at the other thing that's very popular. GPUs. What do GPUs do really good?
Pretty crowded.
They're designed for floating points. but they also have to take that into consideration. But they're designed for floating point, I should say GPU versus CPU. There we go. There we go. GPUs and CPUs do different things. So CPU is general purpose, GPU is special for parallel repetitive calculations. It's really good at floating point numbers. It doesn't say that here, but they are. Yeah, because it's you use them to do all this stuff. And they work together. All right, so that's pretty serious. Is all this stuff important?